Hello learners, welcome back to my channel Shraddha's Physics. So in this part we will see the zero crossing detector. So here you can see the two diagram or the two figure. You can see one for the across the inverting signal, the signal is given, and in the second diagram you can see across the non-inverting terminal the signal is given. So now we will discuss about the zero crossing detector. So the basic function of the zero crossing detector here we are going to discuss. So the zero crossing detector, it is a circuit in which the output changes when the input voltage it just crossed the 0 volt. It may be from 0 to the positive volt or it may be 0 to the negative volt. Okay. So the zero crossing detector, it is a voltage comparator in which one of the input is grounded. So if I will draw, suppose this is your op-amp having one inverting and another one is a non-inverting terminal, and here this one is your inverting terminal and this one is your non-inverting terminal, and suppose across the non-inverting terminal we are giving a signal across this non-inverting terminal, and here the inverting terminal is connected to the ground. Okay, and here this one is your output, and here some power supply is given to this op amp. So here this is suppose plus V, or this is your plus Vs, and your this is suppose minus Vs. Okay, this is just like this. So let us write this is your suppose V in. Okay, so now if I write here the input voltage, the input voltage, that is Vin, is applied to the, it is applied to the non-inverting terminal. You can see here we have applied this signal across the non-inverting terminal, and the inverting terminal and the inverting terminal is connected to the ground, or the inverting terminal is grounded. Okay. Now, what is the basic function of this zero crossing detector? It is that when this input voltage, that is this V input, when it goes slightly positive, that is just when it will just cross this zero voltage, then the output voltage will be plus Vs. Okay, and also if this input voltage, that is this V input, is slightly negative, that is it just crosses this 0 volt, then the output voltage will be equal to minus Vs. That's why its name is zero crossing detector. When this V input signal is given slightly positive value, that is it just crossed the 0 volt, then in the output will be plus Vs, and when this input voltage will just cross the 0 volt and it will give the slightly negative voltage, then the output will be equal to minus Vs. That's why it is called the zero crossing detector. Now let us write these things. The input voltage if the input voltage, that is Vin, is slightly positive, that is it crosses 0 volt, then the output voltage, that is Vo, goes to maximum positive voltage, that is plus Vs. And similarly, if the input voltage, that is Vin is slightly negative, that is crosses 0 volt, then the output voltage, Vo, goes to maximum negative voltage, that is minus Vs. So this is the basic function of the zero crossing detector. Now I can give you the example of the inverting zero crossing detector. Now let us draw the inverting zero crossing detector. Suppose this one is your op-amp, that is your operational amplifier, and it has the two terminal, one is inverting and another one is the non-inverting terminal. And this inverting terminal, it is given the voltage, suppose V input, and this is your inverting terminal, and this one is your non-inverting terminal is connected to the ground. Okay, this non-inverting terminal, it is connected to the ground. This one is your output voltage VO, and here the power supply, this is your plus Vs, and here this is your another terminal minus Vs, and here the voltage is suppose V2, and across the non-inverting, this is suppose a voltage Vi. Okay. Now in this case, you can see in case of the inverting zero crossing detector also, the output voltage, so here I can write the output voltage, that is equal to open circuit voltage gain, open circuit voltage gain, open circuit voltage gain into the potential difference across the two terminals, so it will give the output voltage. Now we can write this VO, will be equal to, that is the output voltage equal to the voltage gain, open circuit voltage gain, into the potential difference, that is your VD, the differential voltage, or this can be written as equal to, or VO will be equal to A into, so the VD will be equal to, you can see, so this is your non-inverting terminal voltage is V1 and the inverting terminal voltage is V2. So the differential voltage will be equal to V1 minus V2. So I can write this will be A into V1 minus V2. And also you can see the non-inverting terminal is connected to the ground. So here simply we can write V1 will be equal to 0. Since this V1 equal to 0, or we can write simply the output voltage will be equal to minus A into V2. Since V1 equal to 0 and it is connected to the ground, so here this output voltage will be equal to minus A into V2. Now if I plot, so let me calculate first. So suppose if I will put this V input is greater than 0, that is when it just cross the 0 voltage, that is it is slightly positive. When it is slightly positive, then we can say the VO will be equal to, this is your minus A into V2. So this is simply minus Vs. And also if V input is less than 0, then VO will be equal to plus Vs. Okay, this is for your inverting zero crossing detector. This is for the inverting zero crossing detector. Now if I plot the graph, you can see, suppose this is your V input. For the V input, here I am plotting the graph, so you can see, suppose, let me draw first. This is suppose the input signal. Okay, this is suppose the input signal. Let me write this is your V in. Okay, now what is the output signal? So you can see when this V in is greater than 0, so you can see this is your minus AV2. That is your, the signal will be equal to, now the output voltage will be equal to minus into Vs. Okay, so the negative voltage you will get. So here the voltage will be the negative when this value is a positive, when the input value is positive. Now you can see if I will plot the graph, then this will be just like this. Suppose this is your minus Vs and this is suppose plus Vs. So this will be the negative. And again, when this part is negative, then also we can say when V input is negative, that is less than 0. So for that case, VO will be equal to plus Vs. So now this will be plus Vs. And similarly for the plus V input, again this will be negative value, and again for the negative V input, this will be positive value. So here you can see the output voltage will be in this form. So this is your output voltage. Okay, this is your V output. Now we will see what are the application of the zero crossing detector. So from the graph it is clear that it can be used as the sine to square wave converter. It is used as sine to square wave converter. And also it is used to protect the op-amp from damage. It protects the op-amp from damage due to increase in input voltage. Okay. And it is also used to check the condition of an op-amp. We can say it is also used as a frequency comparator. It can be also used, and it is used for switching purposes in power electronic circuit. It can be also used as switching purpose in power electronic circuit, and it is also used as phase meter and time marker generator. But the basic function, that is the important function you may say, it is used to protect the op-amp from the damage due to the increase in the input voltage. That is, when it will cross from the 0 to the positive voltage or 0 to the negative voltage, it will always give the maximum voltage, that is your plus V or that is your minus V. So this is all about the zero crossing detector. Thank you all.